If you go to the campus K drive and you go to class ENGR 442 for concrete design, and then go to this folder called column, you will see there is an executable file here called column.exe. If you double click on that and say that you want it to run, and then wait for just a moment, the Concrete Column Designer program will come up. And this is a program which will calculate the interaction diagram for a reinforced concrete column. First off, you can go up to input. Just like the nominal moment calculator, you can input some information in here. You can input who it's designed by. You can put in a title. And you can even put in a job number if you were ever to use this someday in a design office. And then click Done. And then go back up to Input and go to Geometry. Here we are going to, as our first example, do a 18 by 18 rectangular type or square type cross section for a column. And it's already set with these values of 18 by 18, but we could input different values if we wanted to click in here and edit those. The other thing is that we can put in the number of steel layers that we want. Here I'm going to put in 2, and you do have the ability to put up to 200 layers of steel in here if you really wanted to, but we're just going to do 2. And at the first layer, we're going to say that we're going to put in 2 square inches. And in the second layer, we're also going to put 2 square inches. So that's basically the same as 2 number 9 bars at the first layer and 2 number 9 bars at the second layer. The first layer we're going to put in at a depth of 2.5 inches. And the second layer we're going to put in at a depth of 15.5. And so basically we're putting those bars in 2.5 inches from each edge of the concrete vertically. And then we can click that we are done with our input of geometry. Right now it's, as you can see, it is in the rectangular cross-section mode. We have not enabled flanges over here, so we're not doing this one presently. But with that input done, we can press Done here, and it will calculate the interaction diagram for this column. Now, in this column cross-section, it has placed those 2 layers of bars that we input. It has drawn those 2 bars as just a single bar. This program is only going to tell you where the layers are vertically. It's not going to space them out as they actually would be in the real column. But this is done this way just to keep the input simple. If I didn't do it this way, you would have to add additional input to specify the X and Y locations of every single bar in this cross section, and so I've kept it simple this way. But at least you can kind of see if your geometry is being input correctly because you have this picture being drawn based on your input. If one of these bars turned out to be way down here and it was outside of this outline, it would alert you that you had input something incorrectly. Now, we have this interaction diagram. And let's suppose that we go up to input here and we changed our input information. Right now it's set at 4,000 KSI concrete. Our epsilon U is 0.003. Our yield strength for steel is 60. And we have the modulus of elasticity for steel also. We could put in here 5,000 PSI concrete. Let's do that. And so then our interaction diagram is recalculated. Now let's furthermore suppose that we have some design loads for the particular column that we are designing. Let's suppose that we calculated our maximum M sub u as 150 kip feet, and our P sub u was 550 kips. And so we could input those values. Those would be values that were calculated based on the same load combination, and those were the maximum M sub u and P sub u, and that pair of values is like a coordinate on our interaction diagram chart. M sub u along this axis, P sub u along this axis, and clicking done, we can see there it now plots that point of values that we entered. We can see that it is inside our interaction diagram, and hence our concrete column would be adequate for that pair of M sub u and P sub u. Now we could also go up here and go back to geometry, and we could add some flanges to our column. And so let's enable flanges. And furthermore, let's make the height of this beam, or this column I should say, 60 inches. And then we're going to change D for this bottommost layer of steel to, let's do 57.5 to keep it symmetrical. And then we're going to change the size of our flanges to 12. And we're going to change the effective width to 12. And we're also going to change the width of the beam to 8. And now it will calculate a interaction diagram for a beam, or a column I should say, that looks something like this. And I'm going to click done now, and there's what our cross section would look like, sort of. We have some steel, we have this new cross section, it has some flanges at each end, and we have that previous M sub u and P sub u value we had input, and here's our new interaction diagram. Sometimes we want to calculate a interaction diagram for a column that's shaped like this, and this would be the case for a concrete shear wall actually. And so sometimes concrete shear walls look like this, where you have the wall in between two larger end pieces, which might actually be columns in the building, and the columns are poured together with the wall, and this creates a shear wall that can take axial and bending forces simultaneously. So this has some utility in that type of situation as well. And furthermore, let's take a look at the calculations a little bit here. Of course, it repeats what input you have provided, and then it provides some of the calculated results. A lot of this information here, in fact these last two columns, are actually used to plot this black dotted line. The blue line, incidentally, in this interaction diagram is basically the interaction diagram just without the phi values, and that's basically all the input there. The other thing that you might notice about this is that you can save and print the graph. And if you click this button, you can save the graph as a PDF file. And if you not only want to save it but also print it, you can click this button, and when you click Save As, it will also do the print. You can also save this diagram as an encapsulated PostScript file, and so there's some options for the output. But right now I'm just going to cancel that, and I won't do a print. So hopefully you will find this useful as you consider doing design for reinforced concrete columns.